Good morning.
Good morning, sir.
Good morning,
Good
sir.
morning.
So, what was our last discussion?
Path generation
Sir,
problem.
function and path.
What is the last topic we discussed?
So
Dead
we
center
had to
problem.
start dead center problems.
Yep, we'll discuss dead center problem, and I started little bit. So, let me go to that. Oh, sorry. Time. So, this is the problem we started to discuss. Is it visible to you?
Yes, sir.
Yes.
So, in our last class, this was lecture number 9, and um, so we start here, lecture number 10, and this is lecture number 10, part 1. In this case, we have started the dead center problem where we said that if the two dead centers of a mechanism, dead centers means the extreme positions of a mechanism, these two extreme positions, if they are known to us, then we can find out from that also we can find out what is the mechanism. So in our last class I have drawn this and I said that these are the two extreme positions, and from these two extreme positions you have to find out what are the link lengths, right? And you can see that if I say this is the crank length and this is the coupler length, so the same length should be there for the uh, coupler and crank for this position. And I said that this is the extreme position, but geometrically you can see that this is not the extreme position. There is some error. Okay, because in the extreme positions, the two links, the crank and the coupler has to lie on the same line, or they have to be collinear, the crank and the coupler. So based on that, this configuration is fine, but this configuration is not a dead center because this is not a extreme position. Or maybe maybe this is a position which is some intermediate position. Okay, so this is not a dead center. What we can do to demonstrate, let us let us just uh, modify this drawing little bit. So what I will do to uh, get the actual mechanism, although this is not the way to get the mechanism, just to demonstrate that how the actual mechanism and its the extreme positions. So what we can do, we can shift it little bit. So I have shifted it this way, and now you can see that It is here, and right. So actually, this is the extreme position. Okay, this is some intermediate position. Uh, Let me draw. Okay, to first I'm changing its color so that okay. Now you can see that I we need to change this also. Okay, so actually this length is the stroke length. Just I did reverse. Okay, so this length from this point to this point, this is the stroke length. And these are the two dead centers, two extreme points. Okay, this is one point and this is another point. These are the two extreme points. And for this extreme point, you can see that the crank and the coupler, they are collinear. On the other hand, for this extreme point also, the crank is obviously from this point to this point. They are okay, they are coinciding. So and I have not drawn the crank. So crank is from this point to this point and coupler is from this point to this point. Let us call this point is let let us call it let us call it B1 and this is B2. Okay, so you can see from here that and this point is, let's say this point is O2, the center point where the crank is hinged. This point is O2. Then we have this O2 B1 is equals to link length of crank is L2 and link length of coupler is L3. Then this is L2 plus L3. On the other hand, what is this O2 B2? What is this length? O2 B2? What is this length O2 B2?
L3 minus L2.
This is L3 minus L2. Okay, and let us draw it once again. This angle, what is this angle? This angle is theta 2 1 2, right? From this point to this point. So crank one extreme position, from one extreme position of the crank to another extreme position of the crank. This is theta 2 1 2. The this stroke, okay? Theta 2 1 2. And this is, now can you tell me what is this angle? What is this angle? So let me draw it. The from this point to this point. What is this angle? Can somebody tell? If
Theta
this,
to 1 to minus 180.
ye bolo, theta,
Theta to 1 to minus 180.
theta to 1 to minus 180. ठीक है ना? Theta to 1 to minus pi. This is the angle. Now we'll go for the now we will go for this mechanism. How to get the mechanism. So we will first, what are the information we have? We have the first information is from this point to this point, the stroke length S12 is given and the offset may be given. Okay, offset E is given. Then we have to find out what is the link length L2 and what is the link length L3. Also, we need to find out where is the center, because we can just locate these points B1 and B2. Rest we need to locate. That is the problem, and we are going to solve that problem in this class. Okay, so uh, can we do it? Okay, so I would like to copy the whole thing. Okay, let us solve the problem here. So first thing we will locate this point B1 and B2 because S12 given. So in the problem we have this S12 that is given. S12 is given and the quick return ratio. The quick return ratio is given. QR is given. In our last class, we discussed how to find out from the given QR, you can find out this theta 1, 2. Okay. So the process we will follow is first step is to locate step 1. Locate B1, B2 using S12. Okay. So let's take this distance only. It will be given to you which distance you should take, that will be given to you. But for this case, suppose this distance already it is given. Let us take that distance. Let us take that distance and I'm drawing it somewhere here. Okay, so we have the 2 points 3D mistake. I'm changing little bit the position. Not the position, but the drawing I have changed little bit. And now let's define this is one of the hinge point, and the similar hinge point is here. Okay.
Sir, is the length of is also given?
Length of?
Crank.
No. Length of a crank is not given. Only this stroke length is given. Okay.
Okay, sir.
Stroke length and quick return ratio. Okay. Two things are given: stroke length and quick return ratio. Okay.
सर ऑफसेट का लेंथ भी नहीं है.
Offset is optional. It might be, sometimes it is given, sometimes it is not given. Okay. So if it is not given in the problem, you can assume any offset, and if it is given in the problem, you have to use that. Okay. This length is 1, 2. This length is given to us. Is 1, 2. This is given to us. We call this point as B1 and this point as B2. Okay. So our next task is to locate this point O2. Now, how to locate this task? Means how to locate this point. To locate this point, we will use one theorem which I am writing here. The theorem is the angle subtended by an arc. The angle subtended by an arc is double the angle subtended by it, double the angle subtended by it at any point at any point on the remaining part of the circle. Any point on the remaining part of the circle. All of you know this theorem, right?
Yes, sir.
Yes, sir.
Yes, sir.
Oh, okay, now we will use that. See how to use that theorem here. Just see this angle. This angle is known to us. That is theta to 1 to minus pi. Right? Theta to 1 to minus pi. Okay. If this angle is known to us, that means now you follow the step. Suppose we have these 2 points. Follow the step what I am doing. We use the same angle, this theta to 1 to minus pi. Okay. For our, tell me some angle so that we can make our calculations easy here. Suppose this theta to 1 2, this is theta to 1 2 minus 180 degree, and this angle, let's say this angle is how much is this angle approximately? This angle, let's say 40 degree. Okay, theta to my theta to 1 2 minus pi or 180 degree. This is equals to, let's say, 40 degree. This side I have written in radian, this side I have written in only for our drawing. In your case, this will be given. Okay, this will be given. From that you can find out what is this angle. Suppose for this case that angle is 40 degree. Okay, so if this angle 40 degree is given, now you can draw a circle passing through this point O2, B2 and B1. Then the the arc, if you consider this arc B1, B2, that will have some this arc B1, B2 on the circle will create some angle at the center. Okay, that angle and this angle, what is the relation between them?
Half
Three.
of the given angle.
Yes.
That angle is double of it.
No, the B1 and the center of the circle B2, that angle is double of this angle, right? Because this the B1, B2, this arc is creating some angle. This is one point on the circumference. Let us do that. Let us draw and then you will understand. So what we will now do, we will draw a perpendicular bisector of this B1, B2. So we will draw perpendicular bisector of B1, B2 to obtain a point C. So first we will draw the perpendicular bisector. To keep it simple, I draw circles. And now you can see that we can draw the perpendicular bisector joining these two intersection points. So this is one intersection point, this is another intersection point. So joining these two intersection points, I can draw so with the perpendicular bisector is drawn. I'm removing these circles. We have drawn this perpendicular bisector. Now we have to locate the center of these 3 points. This one, and this one. So that center point is C. To do that, what we will have this B1, C, B2. This angle is equals to twice the angle theta to 1 to minus pi. For our case, we have assumed uh, this angle is 40 degrees. So double of that, that means this is okay. This is 40 into 2, 80 degrees. So this one line from here, one line from here, and the whole angle is 80 degree. That means from this point to this point, this angle has to be 40 degree. Okay, to get that, let us just take the same line Let's just take the same line and we will rotate it by 40 degree. Okay, and I'll take it to the this point. Okay, now you see that this line is 40 degree inclined. Okay, let me not do this. It is taking some time. Okay, from the intersection point to one of the point, this angle. Now tell me what is this angle?
40 degree.
40.
Yeah, 40 degree, but we will write it. The this is theta 212 minus pi, right? Anna, here we have chosen 40 degree, but it is theta 212 minus pi. Okay. So then you know that the same line, if we rotate it by this, and you can shift. Sorry, what we did. We need to make a duplicate and then rotate. This line must be placing somewhere here. Okay. So we can say that this point is point C. Is it fine? Are you fine with this point C? How we have obtained point C?
Yes.
Just
Yes, sir.
okay. Now to complete this theorem, we now have to locate this point O2. Okay. So another condition we have, our next task is to let me not disturb this space. Here I am writing locate O2. Okay. Our next task is to locate the center of this mechanism, this crank O2. To locate it, this O2 is a point on the arc which is carrying this B1 and B2. Okay. And another information we have here is the offset. Either you can choose the offset or it is given. So suppose the offset is given and the offset distance is, let's say, from um, offset distance is, let's say, from this point to where I should take. Suppose this is the offset distance. Okay. Offset distance is, let's say, E is the offset. This distance is given or you have assumed. Now we will have a line. We will have a line which is parallel to this line B1 B2. If we draw it like this, suppose we call this line some line xy line. So on this xy line, somewhere the center should be there because the offset distance is this one. So on this line, the center means O2 point should be lying on this line because the offset distance is this much. All right, now, or you can extend it to this point or this. Actually, the center B is here at this level. So you can say that the distance from the hinge point is this much. Okay. Next is to draw the circle or the arc passing through these points B1, B2 and O2. Now where is point O2? Have we got the point O2?
At the intersection of circle and
Yeah.
parallel line.
So this is the point O2 we have. Okay, this is the point O2. So let us write down it. This point is O2. Once we have this point O2, what is left? We need to determine what is this length L2 and what is this length L3. Now see from here, suppose I want to find out on this line only, I want to find out what is this length L2 and L3. So O2B, this length, you see here O2B1, this length is L2 plus L3. O2B2, this length is L3 plus L2. Suppose I extend this line O2B1. Okay, I am drawing a line. Suppose I draw a line O2B1. Okay, and then we want to extend the same line O2B1. This O2B1, we want to extend this line. Why we are extending will be clearer right now. Suppose we have extended this line and we have a point D here on this extended line. Now I am saying that this B1D, what is this line DB1 or B1D? B1D. This D point we have chosen such that lie on the arc. Let us draw the circle, or I can draw the arc only. Intersection point and this point. So I am drawing one arc starting from this P2 to this. Okay, and we say this point D is nothing but this point. Okay, So this D point is on the extended line of this O2B1, and now you can see that this O2D, what is this distance? O2D is
L
O2
L2.
O2B2, right? O2D is
Yes, sir.
O2B2, right? Now if I
Yes.
want to write down this distance B1D, what should I write? B1D is equals to O2B1 plus O2D. Is it fine?
Yes, sir.
Okay, now O2B1, from here you can write down what is this? L2 plus L3, right? O2B1, L2 plus L3. यहाँ से लिख रहे हैं L2 plus L3. And what is O2D?
L2.
L
L3 minus L2.
O2D is nothing but O2B2. What is O2B2 is L3 minus L2. So finally, what is this distance B1D?
2L3.
2L3.
To L3. Now, if we draw a perpendicular bisector of B1D, okay. If we draw a perpendicular bisector of B1D, then we will have the intersection point is the distance L3 from B1 point, right?
Yes, sir.
Let's do that. So to do that, we first draw the perpendicular bisectors. कुछ ज़्यादा ही बड़ा, but I don't have. ठीक है, इसको ही करते हैं. Will they intersect properly? This can serve our purpose. So let us join these intersection points. This is one of the intersection point, and we have the other intersection point is here. Okay, and let us remove this. Now we have the perpendicular bisector. This is the perpendicular bisector, right? So if we have the perpendicular bisector, we can draw this point, which is the perpendicular bisector. So can we say this point is the point A1? And can we say that the mechanism this is A1, and can we say the mechanism is O2 A1 B1? Do you see the mechanism? O2 A1 B1 is the mechanism. That means this O2 A1 is L2 and A1 B1 is L3. And we now have the complete mechanism. To complete it, I am drawing the circle on which the crank, the end point of the crank will, will be there. Okay. Okay. So this is the solution to your slider crank mechanism. Okay. Can you see it? Hello.
Yes, sir.
Sir, we
So,
also had to do it like this in the exam.
huh?
In the exam, we also have to do this like this.
Yes, you have to draw. Any problem? Is it fine? Do you have any doubt on it? How we obtain
Then
this mechanism?
if offset is not given, then how to?
You assume some offset. This offset is not given, then assume some offset. 2 millimeter, 3 millimeter, 0 millimeter. Okay?
Okay, sir.
0 not possible. Be some issue. Okay, then okay, so I repeat the process once again. The in this process, the given data is your the stroke length and the offset. Okay, sorry, stroke length and the quick return ratio. Okay, using this given data, what you need to do, you need to get the mechanism. So first we have uh, located these 2 points B1, B2, and then we have drawn a perpendicular bisector of this line joining B1 and B2. On that perpendicular bisector, we got a point C such that this B1 C B2 is equals to twice this angle. Okay, what is this angle? This angle is the angle between this 2 point, the B1 O2 B2. Okay, then what we did after we get this point C, we have the given offset or assumed offset. We have drawn this XY line. Then we have drawn a circle whose center is at point C and passing through point B1, B2. This circle intersects the XY line at O2, that is the center point for the crank, the rotation. Next is we have extended this B1 O2 line up to a point D such that O2 B2 is equals to O2 D. Okay. Once I get that, then we have this distance B1D, which is twice the length of the coupler. So we have drawn the perpendicular bisector of this B1D so that this B1 to A1, this distance is L3. Now, finally, we have this B1 A1 is L3 and O2 A1 is L2. So we got the mechanism. Is it clear to you? Any doubt? If no doubt is there, let's go to the next topic, that is to obtain. This is our lecture number 10, part 2. Here we will discuss the how to get a crank rocker mechanism. This is also a dead center problem. Dead center problem. Dead center problem means the dead centers are given. The two extreme positions are given. We have to obtain the dimensions of the links for a crank rocker mechanism. Crank rocker mechanism. Okay. What is given in this case? In this case also the two extreme positions theta 212 and theta 412, these are given. Theta 212, theta 412 and the quick return ratio. Quick return ratio means the crank is rotating. So from theta 1, theta to position 1 to position 2, there is a ratio we have already defined in our previous discussion. This ratio is given by this 2 pi minus theta to 1 2. And from the algebra, we can find out this theta to 1 2, which is equals to 2 pi r divided by 1 plus r. So if the r is specified, from that r you can find out this theta to 1 2. And the two extreme position in this case for the 4r linkage mechanism. Suppose this uh, suppose let me draw it freehand. This point is, let's say, O2 point, and let's say this point is O4 point, and you have one of the extreme position. As we said already, we have discussed in the extreme position you have the two links are collinear. Okay, so one of the extreme position is this one. In this position, suppose the link 4 is here. This is O4, this is link 4, 2, 3. One of the extreme position is this. Now the crank is rotating in this position, in this direction. So the other position, we will get the other position by, suppose I have choose this point from here. It is rotated to this point. Okay, the so it is rotated the from this position to this position. Okay, so we are saying that the crank is rotated up to this point. The new crank position is this one, and this is one of the extreme position, and we are calling it position 1, or in the Roman letters. And the other position is, this is position 2 of the follower. Okay, if the follower is rotated like this, and then just see if we have this is the point, this is the length of the coupler. So not a good idea of this. We cannot have with these dimensions. Actually, we cannot complete this. I cannot show you. All right, for just for your understanding, suppose from this position we have another position here, keeping the coupler length same. For this drawing, you can see that length is not same. But suppose this is again length 3, and from this point to this point, this is length 2. So this is the another extreme position. Okay. So what happened to link 2? Link 2 is rotated this much from this point to this point. Okay, and this angle we call it theta 2 1 2, as we did for the last case. From one extreme position to another extreme position. In the next extreme position also, the crank and coupler are collinear, and at the same time the follower is rotated by this angle theta 4 1 2. Why we are writing superscript 1 2? Because it is moved from position 1 to position 2. Okay, so in this case you see that the two extreme positions are given, or this r, if this r is given, from that you can get this theta 2 1 2, and theta 4 1 2 is given. So the two extreme positions of the crank and follower are given. Using this given data, we have to find out what are the lengths of these links L2, L3, also L4. Okay, this is the problem we have to solve, and this is a dead center problem. Okay, in previous problems the requirements were different. We have solved this 4-link mechanism where the requirements were different. There sometimes the position of the coupler, 3 position of the coupler were given, sometimes 1 point on the coupler was given, and sometimes the coordinated motion were given, intermediate coordinated motion between the crank and follower, that was given. From that we have to find. But in this case, this problem is different from those problems where the extreme positions were given. If the extreme positions were given, and from that we have to find out what are the link lengths. So if you allow me few minutes, 10 minutes extra, I can complete this drawing today. Shall I do it? Are you there in the class?
Yes, sir.
Yes, sir.
So I am solving this problem, just method I am giving. Okay, you please note down the steps. Okay, so first step is we define the positions of the 2 points O2 and O4. It can be, it may be given or it may not be given. In that case, if it is not given, in that case, you have to uh, assume some position which are given to us. Okay, so these are the 2 points. Suppose these are the 2 points we have for the points O2 and O4. I'm writing here. This is O2, O2, and this point is O4. Please note the step. First, I am not going to write the steps. Just note the steps. We have first located point O2 and O4. Next is we will locate the relative poles. I have not discussed what is a relative pole. Just here we will learn it. What is a relative pole? So we join these 2 points O2 and O4. To get the relative pole, we need to draw a line which is making this theta to 1 to for R12. We want to get the relative pole R12. So to get the relative pole R12, we need to draw a line. I am drawing that line here. Just be with me. I am drawing a line here, and I am sorry. I am drawing another line passing through this point. Okay. Let me extend this line a little bit. Here, this angle something has happened to it. Okay. So this angle is theta to 1 2. We can theta to 1 2 divided by 2. We can call it theta to 1 2 negative of that. And why negative? Just consider this line. And initially when this angle is 0, the line was here. Now we have rotated the line in the clockwise direction, and in this case crank is rotating in the anti-clockwise direction, so the measurement of the angle is just opposite to that, and we have drawn this angle is theta to 1 2 by 2. Okay, to get the relative poles R12, we have to rotate the line which was initially at 0 degree. We have rotated it by this angle, and similarly we have rotated this line by theta 412 divided by 2, and it is also in the opposite direction. These two angles are given in the problem. Okay, so first step, we have drawn these two lines which are inclined this way, and the intersection point is called the relative pole of this O2 and O4. So this relative pole is R12. Now we will draw perpendicular bisector of O2 perpendicular bisector of O2 R12. Okay. To draw the perpendicular bisector, so these are the two circles we have drawn. Now we draw this line, which is the perpendicular bisector. As usual, I am removing this lines. Only the perpendicular bisector is there. I call this point, this intersection point, as C1. Okay, this intersection point is C1, and we now have this perpendicular bisector is intersecting this line as at another point, and that point we'll call C2. Okay. So can I make it little bit darker? Let us give this color. Okay, so C1, C2 we obtained. This point is C1, this point is C2. Now we will draw two circles using these points C1 and C2. Okay, center, keep this point C1 as center and O2 C1 as radius. This is one circle. Okay, I will draw another circle. We'll draw another circle from C2 as center and the radius is O2 C2. Okay. In the next step, what we will do this, we will draw a line O4Z which is just double of this angle. Okay, so how to do that? Let's say, let me try this. I select first, let me do it and then I'll tell you what we are doing here. Let's say I rotate it by 10 degree, another 5 degree, minus 10 degree, 5 degree, 15 degree, minus 1 degree. So 14 degree, not exactly horizontal, but let us say that this is almost horizontal, maybe 0.5 degree angle different is there. So maybe this is how much we have rotated. If we take it 14 point half, 14 point half, so 28, 29 degree. Then first we have, what are the sequence of rotations I have given to it? This line,
14 degree.
total rotation I have given 14 degree, right?
Yes, sir.
So what we will do now is, let us give it a rotation of minus 29 degree. Okay, and I will shift it to this point. Okay, maybe it is not correct, but so actually what we are doing here, so we want to make a line which is this inclination. This inclination is theta 4 1 2. We want to give this inclination to actually get the line, or you can draw it here. This is theta 4 1 2. Okay, once you have this theta 4 1 2, and this line is, we'll call it O4 Z line. Once we have this O4 Z line, then this bigger circle, on this bigger circle, choose any point. This point is crucial, please remember, please pay attention. On this bigger circle, we will choose a point which is above this O4Z line. We will choose one point on this bigger circle which is above this O4Z line. So you can choose any point. Let us choose a point on this blue circle, and that point is, let's say that point is this point. And we will now make, since we have chosen a point on it, so this is the point we have chosen. And this point is actually our point B1. This point is B1. Okay, B1 means, so the mechanism, the length O4B1 is the follower length, and when you join this B1O2, when you join this B1O2, that intersects the this circle, the smaller circle at this point, right? This intersection point is the another point of interest, and that point of interest is A1. Okay, sorry, this drawing I have not drawn correctly. On this circle, we have to draw it on this circle. Point A is here. Okay, so this point is O2, this point is A1, and this point is B1. So your mechanism is now is O2, A1, B1, and then B1 to O4. ठीक है. O2, A1, B1 and O4. This is a crank rocker mechanism. Using this, you can get a crank rocker mechanism. And as you can see that this is one of the extreme position. Okay, one of the dead center, position 1, where the crank and the coupler, they are on they are collinear. Okay, this is the position 1, extreme position. Okay, then when the crank rotates on a circle, okay, it will go to some other position, when again these two, the coupler and the crank, will be on the same line and the follower will be at some position. That angle will be this theta 4 1 2. From the drawing only you can see that this theta 4 1 2, when theta 4 1 2 will be completed, means the other extreme position, these two, the crank and the coupler, will be almost horizontal. Okay, will be almost horizontal. Almost the three links will come at the same line, but not actually. These two will come at same line here, somewhere here, and the follower position will be like this. Okay. So with this, we are at the end of our discussion on dimensional synthesis.
सर
Yes.
सर जितने भी केसेस इसमें स्टेप समझ में आया सर, स्टेप का सर लॉजिक समझ में
हमें तुम्हारा बात ठीक से सुनाई नहीं दे रहा. बोलो. हेलो.
सर प्रीवियस जितने भी केसेस थे उसमें लॉजिक समझ में आया सर, हर एक स्टेप का. बस
Yes.
सर इस केस में
I have purposefully done this for your you need to study. Okay, what you need to do, go and open the book. First learn about, so then let me give you one home assignment here. This is home assignment 2. So in this home assignment, what you will do, you will learn about the use of poles, use of poles and relative poles. Okay, using this you need to synthesize 4R mechanism. Okay, this is your assignment 2. When you complete this, the logical steps will be very much clear. Okay, एक मिनट में, ठीक है ना? Okay, any other question? If no question is there, let me stop here and thank you for your attention.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.